Hi, I'm Mike Stanzik and this is Digital Electronics Classroom. In this video we're going to be looking at number conversions. We're going to convert from a decimal number into an octal number. And if you watch the video where we converted between a decimal number and a binary number, this is going to be a little more complex because we have to add a step because we're not just going between two zeros and ones and whether it's a number is present or not, but we have to look at the fact that there are coefficients that can be a range of between 0 and 8. So let's get started. So we're converting from a decimal to an octal number. And we're going to use the process called successive division. And in that process, we will continue to divide until our quotient is 0. Oh, I clicked the button. I clicked the button. And so the quotient is 0. That just means that the number is 0 when we make our division there. Okay, and then we're going to get remainders, and our remainders are going to have the range of 0 to 8. Okay, so let's go ahead and do an example. So let's start with the number 309 in decimal and start our divisions. And so we have 309 divided by our base, 8. Okay, we're going to continue to divide by 8 here. I should put that in. Okay, so 309 divided by 8. And if you put this into your calculator and you make the division and you are in non-exact mode, you're going to get the number 38.625. And so remember, we want to build the quotients and the remainders is going to give us our octal number. And so 38.625, great. We have a quotient of 38, amazing, and then we have a remainder of 0.625, but we want our remainder not to be 0.625. We want it to be an integer because we're trying to write this as a number inside our octal number. So what does that mean, 0.625? Well, when we divided by 8, we got 0.625. So if we want the integer number, we have to take that 0.625 and multiply it by 8 to get our remainder. And so this takes 2 steps. First, we have to take away the quotient. And so we minus 38 and we get 0.625. Now you don't have to do that the way I did it as an operation. You could just do it in your head, so that's fine. And then we have to multiply that by our base, and we multiply it by 8. And if I multiply 0.625 by 8, I get 5. And so our remainder here is 5. So we can continue to do that. So now I have my new quotient, which is 38. I can take 38 divided by 8. And when I do that, I get 4.75. And then using that same process, I take the 4 into the quotient, and then the 0.75 multiplied by 8 gives me the number 6. So the remainder is 6. So let's kind of divide these up. And so now we have the quotient is 4. So 4 divided by 8 gives me the answer 0.5. And so there's that 0. That's telling us that we're going to be done here. And so then that 0.5 multiplied by 8 gives me the number 4. And there it is. And so our octal number is 465, base 8. So remember, we start at the bottom and we go to the top. And so we have 309 base 10 is 465 base 8. Okay, not so bad. So we just have to take into account that our remainders are going to be non-integer numbers, and so we have to multiply those by the divisor 8, or base 8, and then we get a remainder that's an integer number. So let's look at our second method, and that's using a table. So we're going to make a table of powers of 8. We're not going to need a whole lot because the numbers are going to get pretty big pretty quick. Remember, each time we're going to multiply by 8. So 1 times 8 is 8, 8 times 8 is 64, and 64 times 8 is 512. And so now we have to ask the question, do I need this number here? Do I need it? And how many do I need? So again, there's going to be a couple of steps in here. So let's take our original number. We got 309 base 10. Okay. So do I need 512? And the answer is no, I don't need 512. And do I need 64 to make 309? And the answer is yes. How many do I need? Well, we have to do some operations here now. So I say 309 divided by 64 will tell me how many I need. Okay. So I do that and I get a number that's 4 point something. And I don't care about this something because I want an integer number in my octal number. I want an integer there. And so 4 is the answer I'm looking for. Okay. So if I wanted to start building this up, the first digit is 4. So we divide by the largest number we need. We're going to get the leftmost digit, the biggest digit that we need. Okay. So great. I used 4 64s. So how much is that? So 4 times 64 gives me a value of 256. Oops, 256. So I counted for 256 of the 309. So I have to take away that from the 309, and that leaves me with 53. So I have 53 left to take care of. So I have to take care of that 53. So 53, well 64, we don't need any more of them to take care of 53, so 53 is less than 64. Do we need any 8s? Yeah, 8s can go into 53, so we're going to use some of those 8s. How many do we need? Well, let's divide by 8. So if I take 53 and divide it by 8, what I get is 6 point something. And again, I don't care what that something is. I just know that I'm going to need 6 of those 8s. And so 6 of those 8s is going to give me 48. And so then I can take that 53 minus that 48 and leaving me 5 remaining. Okay. And so my next number here is that 6. So we need the 4, and then we need the 6 as we build our octal number. So now I'm left with 5. So I need to account for 5. So I accounted for, where is it? I accounted for 256 in this first number, 4. And then I accounted for 48 more in this 6. And so we have 5 left to account for. There's going to be a cut. Okay, so we're back to our table now. We have 5 to account for. So do I need an 8 to account for that 5? No. So 5 is less than 8, so I need some 1s. How many 1s do I need? Well, if I take that 5 divided by 1, and we just get 5. And so that is our answer for our last digit, 465, base 8. And we are done. So that's how we use a table to figure out what our octal number is given a decimal number. Thanks for watching. Hope you enjoyed.